Welcome everyone. My name is Roland. I will be speaking to you today about Rust, which was voted the most loved programming language according to the Stack Overflow Developer Survey. I'm speaking in English because there are some people here who prefer English. If anyone doesn't understand me or something, just feel free to ask if something is not clear. All right. A little bit about me. I worked at Google between 2014 and 2018 at the Zurich office. I worked as an SRE on the Gmail team, and I worked as a software engineer on the Google Calendar team. Then I moved back to Romania, and I've been working on various machine learning projects since then. Currently, I'm the team lead of an AI and machine learning team at a company called Archive360, based in Cluj. I have a blog at rollies.ro. Please read it. I try to post interesting tech content as well. And I started playing with Rust last year in September. This is something I started for fun in my free time. I'm not doing it for my job or anything. I heard that Rust is a cool language, and I said, hey, I want to check it out. And it's true. It's a really awesome language with lots of new ideas put into it, lots of good ideas that make it a very powerful language. So that's why I wanted to share it with the people here. What's so awesome about Rust? So what is Rust language? Its motto is a language empowering everyone to build reliable and efficient software. That's straight from their homepage. It's a relatively new language. It was announced by Mozilla in 2010. So compared to other languages like Java or Python or C, it's like fairly new, 10 years old. The first stable release came out in 2015. That's when the first 1.0 version came out. It's still under very active development. New releases are coming out every 6 weeks, and they add big new features once or twice a year. How does Rust achieve its motto? It has a great focus on performance. Everything in the language and the standard library is concerned about being fast and memory efficient. All the abstractions that it has are zero-cost abstractions, meaning you cannot implement them any better. Also, it doesn't have a garbage collector, which, as much as garbage collectors have improved in the last 10 years, still impose a certain latency performance on all applications. I'll explain a bit later how it can get away from the garbage collector. It's a very reliable language. One of the core focuses of Rust is writing correct software that handles all the errors correctly, that handles edge cases, and doesn't just crash and leave you with an unreliable state. It achieves this by having a very rich type system in which you can encode many constraints on your types and constraints that come from the business logic sometimes. And it introduces a new concept called ownership tracking, which I'll explain in a second, which enables it to guarantee memory and thread safety. Meaning it's very hard, or actually it's impossible for that in a valid Rust program that compiles to have problems that where two threads overwrite each other's memory and so on without you explicitly telling it to, and even then it's quite hard. And it's also a very productive language. It has amazing documentation. There's a very good free book available on its website where you can learn it from. The community is very friendly, and you can go and ask questions either on their own forums or on Stack Overflow and IRC, and you'll get very friendly people explain to you some basic concepts and telling you how to improve your code. I did that myself. I sent some piece of code for review, and I got back really good feedback. The Rust compiler also has great error messages. I don't know how many of you have worked in C++, and when you know that you have lots of templates, you often get errors which are several pages long, and then you have to dig through those pages to find that, hey, yeah, you missed a comma somewhere. The Rust compiler has a great focus on giving you meaningful error messages, not just, hey, this is not wrong, this is not correct, fix it, but it's like, hey, this is not correct, this is probably how you could fix it, and it tells you exactly, hey, if you insert a semicolon here, this will compile. And in 90% of the cases, it's correct, and that solved the problem. Besides this, it has great tooling. It has a cargo. This is how the package manager is called, and the build tool. It has IDE support. You can code in Rust in all kinds of IDEs, starting from the IntelliJ family all the way to Vim, and there are plugins for all of them, which give you out-of-the-box syntax highlighting and incremental compiling support and everything you need. It's an auto formatter and has Clippy, a linter, which shows you, hey, these are common pitfalls in Rust. They are technically correct. They will do what you want, but there's a more efficient way to do them. And it catches some 300-something common errors. Or not errors, but inefficient things. Right, any questions so far about Rust? Did anyone work here with Rust, or did anyone hear about Rust before? All right, 3 hands going up, all right. All right, as I said before, one of the most important new concepts, I'm not certain it's entirely new, but in Rust it's a central concept and Rust made it popular, is this concept of ownership and borrowing. And which makes it, because of this, you don't need a garbage collector, but you still don't have to go back to the C++ or other lower level languages of doing manual memory allocation and freeing. The ownership means that each value in Rust has a variable that's called its owner. Each value has only one owner at a time. When the owner goes out of scope, the value is dropped, meaning deallocated, And ownership can be transferred by moves. All right, let's see a super simple example. We declare a new variable x, which contains the string hello world. And on the first line here, x is the owner. Then when we call the function, the ownership is moved here into the function to this parameter. Now x owns it, and after the function call is over, x is deallocated over here. If I try to use it, if I try to use it after that function call, like in the original, I added this print line here, it's complaining that value is moved and you cannot use it again here. This is because Rust guarantees you that x has been deallocated here, so this value no longer points to anything valid in memory, and Rust can keep track of this, so it knows, hey, that doesn't make sense anymore. This, for example, solves many problems such as dangling pointers or other kind of issues where you free a value and then you try to use it again. Rust can keep track of this and doesn't allow you to do that. But of course, we often want to pass around functions, variables to functions and still keep not just having drag and drops right away. And this is solved by the so-called borrowing, which is basically passing by reference. When we pass by reference to a function, we borrow that value to that function, and then we get it back. However, there are some constraints on how you can borrow. You can either have one mutable reference or any number of immutable references, but you can never have both a mutable reference and an immutable reference. It's either one mutable reference or any number of immutable references. And references must always be valid, but this is not as constraining in practice. Because of this, this solves the problem of having various threads or various functions mutating the same piece of memory, which can then lead to data races. And because of this, because the Rust compiler can track who has mutable reference to each piece of memory, it can guarantee you that it's only one function at a time. In practice, let's change the previous example to solve that. We add an ampersand to both the call side and the declaration, and now the program compiles. It outputs this line here, and then this line over here. All right. Any questions so far about ownership and borrowing? Is it clear, or did I lose people? All right. I'm a firm believer of learning by doing projects and not just by going through slides of boring syntax and whatnot. So I'll show you the first project that I did in Rust to learn, namely building a web crawler. What I mean by that is we have a certain URL, and we want to load all the pages that are under that URL, so http rollis.ro/myawesomepost. But if I link to or.techhub.ro, I don't want to crawl that. And I want to write a copy of all those pages that I downloaded. Clear? All right. So the way I'm going to present this is I'm going to show a snippet of code, and then I'm going to show the output and explain in the meantime. And feel free to ask questions at any point. And theoretically, I should be able to write new code and execute it, and I hope it works, because live coding never goes as planned. All right, let's get started. We do some imports. This is the import syntax, use, and the name of the library you want to use. In this case, we import the I/O library to read things, and there is a library called request for making HTTP requests. What a great name. We instantiate the client of this request type, of this request library. We have the URL we want to download, and we tell the client to, hey, prepare me a GET request to that URL, send it, and then unwrap it. I'll get back to unwrap in 1 second. This gives us the response. We show the status, if it was successful or not. We read that into a string from the response, and we show the first 40 characters. This is the output. Status for HTTP rollings.row, 200 OK, and these are the first 40 bytes. All right. We see here that there is this unwrap thingy going around twice. What's up with unwrap? As I said before, Rust is very focused on correctness. This means that in Rust, every operation that can potentially fail is wrapped basically in a result type, which forces the programmer to explicitly deal with the error. In other languages, like for example in C, most function calls just like return one error code or something, but you can easily just move on and not have to deal with that case, and then your program will crash at the runtime. Or in I don't know, Java or C#, you can or Python, failures would throw an exception, but you don't have to think about them up front. You write your program and it works on your machine, but then when you deploy it, it throws an exception and you didn't think about it, you didn't catch it, so your program crashes. Rust, because Rust doesn't want to avoid this, all operations that can fail return a new type called result, which is parameterized of a success value and an error value. This is an enum type basically, meaning it can be either an OK, this is the successful branch, or an error value, which is the case when it failed. In case of success, your result is wrapped in this OK. In case of failure, your error is wrapped on error. But you get this result type back from every operation, and you explicitly have to check that, did I get an OK value back, or did I get an error value back? And then you have to handle the errors. And this is what the unwrap does, is it converts me from an OK value into the actual value that was returned from the operation. And it panics, so it gives an exception if it's an error. Unwrap is normally not that nice to use in production code because you cannot recover from that. It's meant to be used only if, hey, if my program got into this state, there's nothing I can do about it, I might as well just crash. I use it here because it's the cleanest way to handle things. I'll show you a little bit later how to properly handle this result thing. All right. We've seen previously that we have the HTML as a string. And now let's start parsing it and extracting links that we will visit afterwards. We use another library called document, which takes the body as a string. And you can make various queries based on predicates, such as this means find me all the anchor tags in my document. Are people here familiar with functional style programming? That's clear, you know, map, reduce, things like that? All right, some people do, some people don't. So this returns me basically an iterator, let's call it a list, of all the anchor elements in the document. And then with filter map, I call this function over all the elements in that list. And I filter out those that don't have any value, because in some cases you can have an anchor tag, which, for example, doesn't contain href, so a link to another website. Then I convert everything back to a string, and I collect things into a hash set. Collect is one of these very powerful function in Rust, which enables you to convert very easily from any kind of iterator into all kinds of collections, and it does the right thing correctly. Like in this case, it puts everything into a hash set without me having to write a for loop or something to insert things into hash set. All right, and the output for this is, you can see here, we get, these are relative URLs. These are URLs from other web pages. This is linked to the main page. These are JavaScript URLs, relative things in the page. So we get all the URLs, but we don't want all of them, and we have to normalize all of them so that they're in the same format. One thing that I mentioned here is that the href, maybe anchor tags don't have an href value. So this after call here returns an option type. Option type is the lightweight version of a result type. It's used for when an operation can return. It might not have a return value, but it's not necessarily because of an error. Think like searching an element in a list. Maybe you do not have that element in the list, and Rust explicitly returns to you a none type, and only if it finds a result, it returns a value, the sum value. Or in our case, if there is no href property, it returns none. If there is, it returns that the value of the href property in the sum. All right, now let's normalize, write the function to normalize the URL. We pass in as parameter a reference to a string, so we pass it here and borrow this URL, and return an option of type string. We parse the URL using something from the library, and this is how I mentioned before that I did use the unwrap before to get the things out of the result. Parsing can also fail. So in Rust, this also returns a result value, a result type, and this is the proper way to handle it. This match statement is like a switch statement in C++ or Java. You give it the value, and then you have various branches for what you can do. If it's an OK value, I am going on this branch. If it's an error value, I am going on this branch. I'll handle the error value first because it's simpler. Namely, this URL parser doesn't parse relative paths because it expects them to start with the HTTP basically. And so I explicitly check for that if my original string starts with a slash, it means that it's a relative path, and I concatenate my website's name to it and return that as in a sum option. Otherwise, I return none. On the happy flow, so when it can be parsed, I use this shorthand here. If let sum of my blog name equals the host string of the parsed URL, then I return the whole URL as in a sum option. This is basically a clever shorthand for something like let x is a new URL.host string. This will return to me an option type, and then I would have to do if x is sum and x.unwrap equals all is dot row. All this can be expressed with this one line. It's a very weird syntax. Like at first when I saw it, it doesn't look right because it's like you have an assignment operator here, but it's not exactly assignment. It's a syntactic sugar for all of this. Is it clear for everyone what's going on? Okay. And all right, you've seen here that I'm passing in a str, and I'm returning a string. What's the difference between the two of them? Strings are allocated on the heap, and they are owned. So it means that the function that has them is the one that owns them and can do whatever it wants with them. While the str type is immutable, the compiler decides basically where to allocate it, either on the heap or on the stack. And because it's immutable, it's a read-only view of a string. To go from a string to an str type, it's very easy. Usually if you take a reference, you can pretty much, the reference of, so a reference of a string is kind of equivalent to a reference of a string, str. But to go from a str to a string, you have to make a copy because you want to get the new owned value, because you want to make sure that, hey, I'm having this value and I can do whatever I want with it. Clear so far? Questions? All right. Okay. To apply the normalization, it's quite simple. I just add a new filter map, and where I pass in my function that we just defined before, and it will do the right thing. It will call this normalized URL on every value that is outputted here, so all the URLs. If my function returns none, it filters them out and it ignores them. And otherwise, if there's something, it unwraps it from the option type. Okay, let's put everything together. There is not much new here, except that we call this function. Sorry, I clicked the wrong thing. Yes. And yeah, now we get a list of nicely formatted absolute URLs. Okay. Next step is, because in our crawler we will want to fetch several pages, not just one, we'll refactor our whole fetching into a separate function. It's not very complicated. We define a new function called fetchURL, which takes as parameter a reference to a client, the HTTP request client, and the reference to the URL as a string, and returns the body as a string. Inside here, there is nothing interesting. It's the same that we did just before. An interesting fun fact about Rust is it has implicit returns. This is basically equivalent with this. So anytime you skip the semicolon at the end of a statement, Rust will use that as a return value for that function. It saves this, I don't know, for saving 6 characters or something. It's a small feature. And now let's get into the meat of the crawler, where we will do the breadth first traversal of the website. The algorithm is simple. We take all the URLs on the home page, we crawl them, we check all of them for URLs, we check that they are new, and then we repeat this until we don't find any new URLs anymore. Okay, yeah. So we have these new URLs which we initialize with the URLs that we found on the first page. While it's empty, we start iterating over them. This .iter function call returns to us an iterator over all the elements of that collection, and we map over it. So we apply this function. This is the syntax for declaring a closure, so an anonymous, a lambda function basically. The Rust compiler is smart enough to figure out the type parameters in this case, so I don't have to explicitly mention that here I have strings. It can figure it out, so it has some amount of type inference. I call the previously defined fetchURL function. I call the previously defined getLinks from HTML function. I show some statistics, and I return the links that we found. And after this, I have here an iterator of vectors of strings. Those strings represent the new URLs that I have found on each page. I want to convert all of those so that they are in a single collection, and I want to remove duplicates. Removing duplicates is done in the easiest way by putting it into a hash set, because then the set guarantees uniqueness. And I use the fold operation from functional programming. Let's And if everyone do people know what the fold operation is? Come on, Josh. I'm sure you were.
Something else in the same languages, but I don't know.
It's pretty much reduce. Okay, so fold is or reduce is a concept from functional programming. It's the preferred way, or not the preferred way, one of the ways there to process lists there. Basically what it does is that you have an accumulator value and a function, and the fold function will apply that function between the accumulator value and each element of your list. So in this case, the accumulator is an empty hash set, and my function, what it receives is the accumulator and an element of my iterator, which in this case is a vector of strings, and it extends my accumulator, so the hash set, with the values of that string. And I return that accumulator, which now becomes the new accumulator. So every time I add in more elements and the accumulator grows, in the end it has been extended with all the strings that I have. I mark as visited all the URLs that we just iterated over, and then we compute the new URLs. We look at what URLs we found. We subtract from them as a set operation the visited URLs because we don't want to visit them again. I call the toString because I want to own these, to make a copy basically of these URLs. And I collect them everything into a hash set. And I print out how many new links I found in this iteration. Questions? All right, and yeah. Okay, this is the output of running this, and as you can see, there is an error. I'm sorry, you cannot see too well. I'll try to show it here. Yeah. So this is the error. Can you see it, or should I zoom in a bit? It's complaining that the result of unwrap operation that we talked about before was called an error type, and the error was stream did not contain valid UTF-8. What this means basically, and what Rust is complaining about, is that strings in Rust have to be UTF-8 encoded. In, I don't know, in C or in Python, you can have your strings being encoded in all kinds of ways, UTF-8, UTF-16, or the old ASCII standard, or Latin 1900 something. In Rust, the decision was made that all strings are UTF encoded. They decided, hey, UTF-8 is the most popular thing nowadays anyway, so every string must be UTF-8 encoded. In this case, what happened was that one of it was trying to download an the favicon, which is an image, and of course that's not UTF-8 encoded, that's a binary data, so the string complained that, hey, I cannot read this properly. We can solve this in two ways, either by reading stuff into byte arrays, or by actually skipping everything that is non-text data. Because I was not interested in getting the images from my own blog, I actually just wanted the HTML. I decided to go the latter way. All right, I don't know. Like my. Okay, my keyboard is not working well. Oh well. To do that, we first check if there is an extension on a URL. For that, we use the standard library path module, which can parse any string basically and tell us what are the components of that as a path. The extension function returns, guess what? Option. and we check if it is none. So this is none is called on any option type, and it returns true if it's none, false otherwise. Both the result and the option type are full of these kinds of helpers, which so such as is none, is some, is okay, is error, and to help you convert and check for things. And we add another filter to our getLinks from HTML function, which this filter calls this function there, and if it returns true, then that value is allowed. If it returns false, that value is removed. All right. Questions so far? Okay. Now we get the output correctly. Let's start writing to the disk. We define a function for this, which receives as a path as a parameter the reference to the path and the reference to the content. We use the createDirAll path. Basically, I want to save. I want to create replicate the folder structure from my blog. So if I have, say, an article under /2020/06/030/ my presentation at Oracle Tech Hub, I want that to be in a folder on dist, which is also 2020 in that is another folder 06, another folder 30, another folder my awesome presentation, and in that I will save the actual HTML as an index.html file in that folder. This createDirAll creates recursively all the necessary folders. So even if one of them is missing, one of the parent folders is missing, it knows how to create them. And then I just simply write to that path suffixed with the index.html the content. All right. And this is the output that I get from there. We get lots of stuff, process a lot of things. And this here is I timed how much this program takes to run. It takes 34 seconds. It's actually pretty good. Like, this is actually on par with what you would do if you try to do this with wget and try to download all the pages with wget. It would give you some similar results. But now, and why does my apologies, for some reason the slideshow thingy doesn't want to work anymore. All right, something eats the slideshow commands. All right, sorry. But in Rust, we can make it much faster with very little changes. Rust has a library for parallelization called Rayon. We include that. And then we make the following. So that's one line of change. We changed previously we had the iter call here. Now we replace it with par iter from parallel iterator. Poof. Rayon makes sure that our iteration is done in parallel. And for reasons that are a bit convoluted, or I'm not exactly sure, but in Rayon, the fold function is called reduce, as Josh is more familiar with. And that's it. That's all the changes we have to make. 3 lines, or not even 3 full lines. I run it again. And this time takes 6 seconds with a change of less than 3 lines of code. And because Rust has the concepts of ownership tracking and borrowing and whatnot, it can guarantee to me that actually this will give the same result as if running in serial. There will be no cases where some values are clobbered or overwrite each other when you do the joining of the hash sets. And this is actually, so it will work as intended. And actually, like the first time when I wrote this, I didn't know about Rayon. and I tried to do it myself with threads, starting threads manually and using mutexes and so on. And it's actually not easy to implement this whole behavior correctly by yourself. Like, I fought the Rust compiler for several hours until I could get something working. Because making sure that the threads work correctly and they insert the data correctly and they don't cause collisions is non-trivial. And as we all know, that concurrency is a hard problem. Well, Rust can help us a lot in this case. All right, so it's a 6-second speed up basically from 34 seconds to 6 seconds with just 3 lines changed. All right, any questions so far? Crickets. David, any questions from you? Come on, maybe you are braver than the others.
You should start from John. He's the first one, right there on your side.
When you mentioned about fighting the compiler to actually get it to run in the first place, was it helpful in? Do you feel like at a certain point you were not going to be fighting the compiler, or is it always going to be the case?
So definitely it was a case of fighting the compiler for the first, I don't know, 1 month or 2 months of me learning Rust in my free time. So like, this is not, I'm not doing it my full time, so I have, I don't know, 3-4 hours a week or at most of doing this. It was quite hard. Some of the error messages regarding the ownership tracking. Okay, I understand what it's saying, and it's telling me, hey, this is moved from here, and you no longer have ownership of this. But I didn't understand why exactly that happened. But for example, that went away after about 2 months. Like, now I'm much more comfortable, and I can see how things, how to make the compiler happy. But the fun fact is that not only I know how to make the compiler happy, several times it happened that in me trying to figure out, oh, why is the compiler complaining about this, I realized, oh, wait, I have a mistake in how I design my API. I am passing the data around in the wrong way. And surprise, by making the compiler happy, I also made a much better API design. Like, in one case, it was like I was passing the data around in 2 ways, and then I realized that, hey, actually, this doesn't make sense. The data needs to go only in the second branch, not in the first branch. So that was, like, for me, a very eye-opening moment. That, whoa, okay, Rust, it's super strict, and initially it's scary, but those are actually good practices that it suggests to you, basically. And eventually, I feel like because of it, you become a better programmer, and you learn lessons which you can apply in other languages as well, even when you don't have this concept of. Sure.
What's the main paradigm of this language? I mean, is any import by the language?
It's a mix of imperative and functional programming.
Okay. Because what's the main point of this language? Why it's so large community?
Yeah. So one of the points of the language is that it's low level enough. It's a systems language. That's what it wants. So it can replace C, basically. And some people are unhappy that if you want to do any low-level programming or embedded device or develop an operating system, pretty much the only option that you had until 10 years ago was C, because that's what, when you needed the utmost performance, C was the king. But you know, in C, it's very easy to make foot guns. And you make a buffer overflow, or you don't properly check a string that is terminated, and so on. Like, we all know all the bugs that can happen in C. And Rust removes a whole class of these errors. And really, you can see looking at the community, so many people start by making, one of their first projects is reproducing one of the command line tools in Linux, like, I don't know, ls or cat or whatever. And it's trivial for them, like people who are beginners in Rust can make a much safer version of that, like which does proper error handling and is as fast or even faster than the tools that come with Linux. Even though those have been around for 20 years and have been added so many options and so many optimizations, it's trivial to reproduce them in Rust correctly. And so yeah, it makes those kind of people happy who have to work on the intersection of performance and where correctness or safety is very important.
Out of curiosity, what you presented here, right, you obviously wrote, but where did you learn all this? Was it only from the official documentation or other places as well? The official documentation, when I tried to learn the language, it was just too raw for me. I didn't understand most of the
Yeah, so
what it was trying to say.
there is this thing called the Rust book. This is more like a tutorial-like thing. Like it goes through all kinds of steps, and it's very detailed. Like it has 21 chapters, and it explains all concepts in quite a detail. But as I said, this is more of the tutorial slides with syntax and whatnot. There's another really cool thing which Rust has. It's called Rustlings, if I remember correctly. Small exercises to get you used to the concepts. By the way, one of the mascot of Rust project is, was it a crab or something? It's a Rustacean. So people who are Rust fans call themselves Rustaceans. And basically, so these are a whole set of exercises like this, where it says, it gives you an unfinished program and some instructions, and it tells you, hey, fix this. And these are all small bite-sized things, like with strings, for example. Here, the problem is that the string literals are of str type, so you have to call .toString here. This is like a very small leap that you have to make, and it actually gives you hints and whatnot, but it helps you get along with the basic stuff and figure out, hey, on this compiler error, this is what I can get. The other thing is that searching on Google or DuckDuckGo, which I prefer, is very useful. Like on Stack Overflow, you find answers to all kinds of questions, and it's surprising that so many times I was like, I didn't get it why the compiler was giving me a certain error, and I thought, okay, its error is too generic, and I won't find the answer to my question. But actually, I did find the answer to my question, even though it was maybe in a quite different way formulated. So, yeah, these two things are what I would recommend for learning Rust. Any other questions?
How did you make this code run in the browser?
Okay, so this is running in a Jupyter Notebook. Do you know about Jupyter Notebook? Okay, so Jupyter Notebook was a thing that was initially made for Python to be able to run things in the browser for Python. It started off as IPython. Then and it's very handy because you can prototype things very easily and run things directly, and it's very easy to share. You can save this as an HTML file. And for a couple of years, people realized, hey, actually, this is very handy. So they added the option of extending that IPython with kernels in different languages. So there is a Rust kernel that I don't know exactly what it does, because Rust is a compiled language. Is there an engine in the browser? No, it's not in the browser. I'm running Jupyter Notebook in the command line. And somehow it sends this to the kernel, which compiles it and patches things together, and now you get this. And it's actually super handy and really nice.
One more question.
Yes.
This language is focused on concurrency, right?
On what?
On concurrency.
That as well. Not only that, but yes, it works well for concurrency.
I think the main engine you work with concurrency is threads, right?
Yes.
Okay. And what's the flow when you send something, some data into the thread? Is it cloned in the thread? You pass the reference.
So
The data in the thread is isolated from the other thread.
all right, yeah. So one thing which I think I forgot to mention, and it's somewhere around here. Right. Right. So by default, variables in Rust are immutable. To make them mutable, you have to explicitly mark them as mutable. Now, if you want to share data between two threads, by default, it's going to send, they're immutable. So if you share them just like that, it's immutable. And in that case, you don't care that all kinds of threads can access it because you know that they cannot write to it. So it's not a problem. When you want to send a mutable variable to a thread, then you have several options. One is to either make a copy and then the thread will work on its own copy and then you have to somehow get that information back. Or you can wrap things into a mutex and arc, that is an atomic reference counter. And that enables you to, so makes the threads know how to collaborate on that variable. You asked what if threads are the main method of concurrency. That threads are also very popular, but this year / last year, Rust also enabled the Async interface, and now there is a big push for writing code in the async style.
I mean, what's the main difference from this point of view, from the point of view of concurrence?
Between threads and async.
Rust, not the language. For example, Java. The same threads, the same mechanisms.
Yes, so Rust, because of the ownership system, Rust can pretty much prevent all kinds of data races, and which you cannot, in Java it's not guaranteed, like Java cannot guarantee that. And while in Rust you can say that, yes, actually this variable will only be manipulated by one thread at a time, which is a pretty strong guarantee and pretty useful most of the time. Any more questions? If not, thank you very much for coming and listening to me.